Good day everyone. Today I'm going to present a report about deploying model using Flask. Let's start with its definition. What is deployment? Deployment in very simplified terms means making your code available for use of end users. For example, if you have a potential model that do you think has great value to the society, then that model would be a big help for every user. And how can other users use your app? Simply, you need to run your app on the computer server that is accessible by the users. And this whole process of testing and running your code on the server is referred to as deployment. What is Flask? Flask is a lightweight WSGI or Web Server Gateway Interface, a web application framework written in Python. Web Server Gateway Interface is a specification that describes how a web server communicates with web applications and how web applications can be chained together to process one request. It has multiple modules that make it easier for a web developer to write applications without having to worry about the details like protocol management, trend management, and the like. Flask gives a variety of choices for developing web applications, and it gives us the necessary tools and libraries that allow us to build a web application. One more important feature of Flask is that it does not impose any additional dependencies, giving the developer a choice in terms of which libraries to use. Steps to deploy machine learning model using Flask. In this process, I use an example that I've got from the internet, and hopefully this will give you an overview in deploying your model. First, getting your model ready. Of course, we have to install the Flask, and Flask here is all matters. The next in line is the model we need to deploy. And we are working in the Jupyter notebook, and our trained model must be saved, and it is been noted that the model will not be trained during deployment. The model used in this process is the MNEST dataset. This dataset stands for Modified National Institute of Standards and Technology Database. It is a large database of handwritten digits and commonly used for training various image processing systems. To save a TensorFlow model, it uses the following code. This TensorFlow is a Python library for fast numerical computing. In this model, it receives the image as an input and returns the result, which is an integer. Next, designing the workflow. Now that we have a trained model, we can design how our server should handle user requests. The flowchart describes the working of our model. In this proposed model, the user uploads an image to the server using an HTTP POST request. Request in Python is an elegant library that lets you send requests to web pages by Python. Upon getting the request, the server sends us back the right content we requested from it. The image is received and saved on the server. We can also check the image for some potential security threats, and the saved image passed through the model, and the result of the model are returned to the user in the form of text. Coding the Flask API. We create a Python file app.py that runs our app. The import statements are the following. Import OS to handle saving and deleting images. This is an OS module in Python that provides a way of using operating system dependent functionality. Import the required function from Flask such as request, flash, redirect, and send file. And import TensorFlow. This is for loading the model. Creating our app. In this part, creates a Flask app with the name same as the file name. And it can refer to this Flask app as app in our program. Next is setting up image upload folder and loading the model. REST API for the app. REST stands for Representational State Transfer and is an architectural style used in modern web development. The app receives and sends data to the user. For that purpose, we need to specify a certain set of rules. The app decorator binds the function upload file function to the app. The function is routed to the base URL specified as /, and the only method that is allowed is post. User can upload to the base URL. The upload file function takes care of many conditions of the file uploads from no file to correct file. This code is REST API for the app or the specified set of rules, and this part of the app is run again and again for every client request, unlike other parts of the code. Run the app. The code says if this file is run as a standalone file, the app will run in debug mode. Get the server app and running. Python 3 app.py. This app.py create an app object, which is an instance of the Flask object, and it will act as the central configuration object for the entire application. The server here is running on a particular HTTP, and that is the app endpoint. Now the app is running on the local machine. It can be accessed the app just by using the URL. Uploading an image. And this approach separates the back end from the front end. On the other hand, makes interacting with other standalone front end apps easier. Even without the front end, can use the good old curl command for uploading an image. For conclusion, the overall deployment of machine learning model in this process is on the local machine, and the user connected to the network can use the app services. That's end my report, and thank you for listening.